today I'm going to talk to you about a story, a true story, my personal story. Some years ago, I was asked to help improve the quality of the software application. It was a big, complex application, and the customers kept complaining that there were a lot of bugs in the application. The developers complained that it was too difficult to fix bugs, and it was also too difficult to implement new features on top of this application. So there I was, looking at thousands of class files, and I really didn't know what to do. Fixing one class file after the other was not realistic. It would take me years. So I needed to find a smart way. For this reason, I tried different approaches, but most of them failed. Fortunately enough, a few of them were successful ones. So that's why I'm here today with you, in order to share this experience with you and help you do a better job than I did, so that you don't have to reinvent the wheel. So one of my first approaches was to use a static analysis tool, SonarQube, which analyzes all of the source code and tries to pinpoint, to indicate some parts in the code that may be defective. It categorizes all those findings into several categories.
Ich glaube, ich kann loslegen.
Okay.
Tag der Woche.
Okay.
Nee, halt.
So.
Still the same name, still the same company. Right.
Can you hear me?
We've done this before. You know what I do. You know why I'm here. You know who I work for. We've done this before as well. We have.
So I invested a lot of development effort, a lot of my time, in order to reduce those findings. And I really enjoyed it. I was feeling really nice cleaning this code. It looked much better. But soon I discovered that as I was cleaning, fixing code, I was introducing new bugs, new defects that did not exist before. So instead of fixing things, I was breaking. So my advice to you would be not to follow the same path, but leave the code as it is. Because in my opinion, the effort that I invested did not pay off. And you know what? There is academic research done on this field that has proven that old code is reliable code. So if we take two modules, the first one is older, 1 year older than the second one, then the first module will have 33% less defects than the second one. So for next time, remember, when you see old code, you better not touch it, because old code is reliable code.
So,
is draw a line with the past. Whatever happened in the past stays in the past. Our number one priority should be to make sure that our code, the new code, is free from defects. What can you do about it? First of all, there is a great tool, a great plugin that you can install in your IDE, whether you're using Eclipse or IntelliJ, that as you type code in real time, finds out some errors that you may have made while typing code, and gives you a real-time recommendation about what mistakes you have done and how you can fix them. And it also has a detailed explanation of how to fix your mistakes. I've been using it for the past 2 years, and I found out many mistakes in the way that I wrote code. mistakes that I was not aware of. So I can tell you from my experience that it has helped me become a better developer.
Can I take this one because they cannot actually.
Well. Okay, can you hear me now? All right. So it only takes 5 minutes to install it in your Eclipse or IntelliJ, and it will help you every day to become a better developer. So I highly recommend this. Besides that, I also installed SonarCube in our Jenkins server, our continuous integration server. So every time that a developer from my team would push new code, Jenkins would compile it, run any unit tests and integration tests, and at the end, it would perform a static analysis. There is a feature in SonarCube that allows you to set up quality gates. Here it is, quality gates. And you can configure it in such a way that it won't allow any new source code to contain any blocker issues, bugs. In this way, you make sure that all of your new code is defect-free, and nobody from your team is allowed to insert more technical debt into your application. So that also helps. It's proven to be really useful. Now it's quiz time, and I will need your participation. So how do you spend most of your time? What do you do? First option. Do you spend most of your day trying to read existing code, trying to understand what it does? Who believes that? Please raise your hands. Only 3 hands, 4. Okay, we have some more. Second option, writing new code. You spend more time writing new code? Nobody? Okay. No code. Third option, waiting for a full build to complete. Anyone? And fourth option, other activities, meetings, coffee, gossiping. Anyone? I see some hands, great. So, according to my experience, we spend, as developers, most of our time trying to read code and understand code. That's how we spend our time. So, can you remember which parts of your code you read most often? Are there some classes in particular that you have to open every single day, trying to understand what they do? You don't have to answer, because all of this information is stored in your version control system. You can run a simple command, as simple as that one in Git, this is for Git, which will give you the number of commits for every single file in your repository, sorted with the files that have been modified most of the times being displayed first. So what does this tell us? How can you modify a file if you don't spend some time reading it, trying to understand what it does? This is a real example from the application I'm working on. As you can see, the first 2 files are the localization files in English and German, and the other ones are all Java class files. So the first candidate has been modified 227 times. For someone to make this commit, she had to read it, understand it, and then, only then, were they able to modify it. So this is where we spend most of our times as developers, opening and trying to understand the same files again and again. So for this given application, we have more than 10,000 files. It's really complex. And believe me, if you are a new developer, you're being scared when you first see those 10,000 files. But a careful analysis shows us that only 11 files have been modified more than 100 times. On the opposite side, we have 9,500 files that had less than 10 commits. So is this pattern only seen in this application, our own application? Is there something strange about it? No, the answer is no. There have been similar studies for open source projects whose source code is open, and we see the same pattern again and again. Our development activity is usually focused on a limited set of files, usually because the customers keep asking for changes and enhancements in some popular features. So now, by running this simple command, you can tell which files in your source code absorb most of your time. This will allow you to perform some refactorings which are well targeted. When we talk about refactorings, we shouldn't be just refactoring random files, but we should be targeting those files that take most of our time. So if you do this and refactor those files, making them easier for you and your colleagues to understand them, you can be sure that you will save a lot of time reading them and extending them, and therefore you can become more productive. So this is refactoring effort well spent. It will pay off. And you know what? We should pay attention to frequently changing files because, according to academic research, those are the files that are responsible for most of the bugs in our source code. Really, there's research. You can also check for yourself. So what can we do? When we test, we should focusing our testing activities on those files that change more frequently. Why should you run tests again and again for files that have not changed for the past years? Why should you test mature functionality, functionality that has not changed for the past years? So you can be smart and test only what matters. Test only the files that keep changing again and again, because we have evidence that those are the files that cause all the bugs. So next time that someone asks you, what is the code coverage of your application? We should better change this question to what is the code coverage of your frequently changing files, because this is what matters. Why should you have a low code coverage in those frequently changing files and a higher code coverage on the rest that do not change? It doesn't make any sense. So be very careful. Next time, ask yourselves, what is the code coverage of my frequently changing files? And this takes us to something that's really important, identifying which features in your source code are mature ones and which are not mature. Which code is too old and which isn't. If you find out that you have code that is old, it could be because this code is dead code. It's not being used. A developer checked it in at some point in the past and it was never used. If you find out that you have dead code, that's why it's old, then don't hesitate. Go ahead and delete it. Deleted code is the best code. So don't be afraid to delete it. If you find out that this is not dead code, it's being used, but it's a mature feature, then this is a very good point to start talking to your customers. Hey, why is this a mature feature? Are you using it? If you're not using it, then I could also remove it. Why should I keep it in my code base? Why should I keep it in my product? Why should I make our lives more difficult? Again, go and delete it. Don't be afraid to delete mature features. On the other hand, if you find out that those mature features are being used by your customers, you can extract this code and put it in another repository, in another Git repository, and treat it in your application as if it were an external library, an open source library. Why would you keep this in your source code. What will you win if you apply those practices that I recommended just now? You will go faster. Why will you compile the same code again and again if it's been there for years? Why? You're wasting time every time you build it on your laptop, every time that you wait for your Jenkins to complete the build. You will go faster. And we also noticed in my team that it was easier for newcomers, for new developers, to feel familiar with the code base. When you have a smaller code base, a new developer can become familiar quicker, take ownership of the project, take ownership of the application, and deliver new features, deliver new value, high value to our customers. So we talked about frequently changing files. There is also another criteria that we pay great attention to. That's code complexity. There are two metrics which are language neutral. So no matter whether you code in Java or C++ or whatever else, we usually count the number of lines. A file, a class file that has 100 lines is less complex than a file that has 1,000 or 10,000 lines. And there is also the number of tabs in front of each line. Has it ever happened to you to solve a customer ticket, a customer bug, by inserting a nested if? So if you find out that we have this weird setup that this customer has, then do this magic and problem solved. Well, if you've done that, then you solve the ticket, but you also increase the complexity. So every time a developer reads that, she or he doesn't know which way the code goes. Does it enter if? Does it enter else? It's really confusing. So that's why we also measure the tabs here. You see the red arrow? The tabs in front of each line. The more tabs you have in a class file, the more complex it is. So we did this for this application that I'm talking about. We made some scripts that for a given file would retrieve each commit. So give me the first commit, count the number of lines, count the number of tabs. Okay, we got those values. Give me the second commit, do the same, third commit, and so on. So we can see how the complexity evolves during the time. This is the first candidate file that I showed you before, the one with the 227 commits. With the blue line, you can see how the number of lines increase, reaching almost 6,000 lines. And with the red one, you can see how the number of tabs increase to 16,000. But then, if we take a closer look at the second candidate, which has only changed 200 times, 205 commits, we can see that it's more complex. And we also have a high increase at some point of time. And if we look even closer, we can see that the lines have increased from almost 7,000 to more than 8,000. The tabs have increased from 22,000 to 29,000. And this was due to a new feature that we delivered sometime in September 2014. So if we had limited time to invest in order to refactor a class, then this would be our top candidate, because it has had a lot of commits, a lot of changes, and it's also more complex compared to the previous one. Does anyone remember Windows Vista? It's been some time since they were released. It's one of the biggest applications with more than 50 million lines of code, and the development team that implemented it consisted of approximately 2,000 developers. So Microsoft had a lot of data about the developers who implemented every component. This was usually DLL, a DLL library, or an exe file, an executable. All those data came from the version control system that they had. And they also had a lot of data regarding the bugs that were opened to each component from the customers. And they also had some assumptions. They believed, but they did not have any proof, that the organizational metrics affected quality. So what do we mean by organizational metric? They said, okay, the more developers I have in a team, the more need for communication I have. They need to communicate between them. If you have 1,000 developers, for example, in a team, it's more difficult for them to communicate. You have communication gaps. Those communication gaps translate to gaps in the business code, in the business logic in the code. And those gaps in the business logic translate to defects. But it was a gut feeling, an assumption. Similarly, they believe that when you have a lot of developers who leave the job, you lose their knowledge about the business domain, the business logic. And that's what is most important. So even if you hire an experienced developer who is not familiar with the business logic, then you have a problem because they will introduce new defects. The same happens when you have many organizations that are geographically separated, disparate. So if you have a team in America touching the same code with another team in Europe and another team in Asia, then you also have gaps in their communication, which translate to gaps in the business logic, and those map to defects. So they analyzed all those data and proved that those organizational structures affect software quality. And they are the ones that are most likely to cause defects, to predict defects, even more than code coverage, code complexity. So all of my life as a developer, I believe that what's important is to write clean code, to write good code, to have extensive tests. But this study proved that there is something even more important, and that's the organizational structure. That's the one that affects the quality of the applications the most. So what can you do about it? They continued this research for Windows 7, and this time they put the developers in 3 different categories. The developer who had the most commits in a component was called an owner. Developers who had more than 5% of the total number of commits were called major contributors. And whoever had less than 5% of the total commits was called a minor contributor. And they came with some very interesting findings. The higher the number of the minor contributors is in a component, the more the defects will be. So you shouldn't have a lot of minor contributors working on the same component, because this will not be good for your quality, for your software quality. On the other hand, if there was a single owner who had a high contribution into this component, then this improved the quality. But again, it could not compensate for the number of, for a high number of minor contributors. If you had many minor contributors, then this owner could not really compensate for this, couldn't save the quality. Those are actual data from the application I'm talking about, from a component, where we can see that we have 15 minor contributors out of 21 contributors, and the owner has only a 20% of ownership. And you can see the commits in this chart that they are quite diffused. This is from another component, again from the same application, where we can see that we have less minor contributors, 3 minor contributors, and a higher level of ownership, almost 29%. What can we tell from those figures? If we compare them, then we can predict which component will have the highest number of defects. The component with 15 minor contributors and lower level of ownership will have the most defects. So remember, minor contributors, more defects. Bigger ownership, less defects. So this can help you in many ways, this finding. Next time that you have a minor contributor working on a new feature, you should make sure that they talk with a major contributor or the owner before making any changes to this component, and decide on the best approach of how they should implement it. And you should also be very careful, pay special attention to code reviews when the code being submitted comes from a minor contributor. And again, you can be smart about testing, about where you will invest your testing efforts. If you have limited testing effort to invest, then you should be testing the component that has the highest number of minor contributors and the lowest level of ownership. So it's all about setting the right priorities and being smart. So next time that a customer comes and asks you a new feature, and the customer wants you to implement it right away, but the major contributors or the owner of a component is not available, you have two options. You either ask for the minor contributors to start implementing this right away, but you know that this will have consequences to the quality of your application, or delay the implementation of the feature for a couple of sprints until someone from the major contributors or the owner is available to work on this. You can find out your contributors, major ones, minor ones, by running this simple command in Git. It's very simple. And you can also filter the results after a given date in order to take into account changes to your team. So if your team has changed, you can limit the results after a given date. So that was all. That's a brief summary. You should stop creating new quality issues. That's the most important part. You should not touch old code because it's reliable code. You should refactor your most complex and frequently changing files. You should focus your testing on frequently changing files, and you must pay great attention to minor contributors. So next time you have to work with a big, complex application that consists of thousands of files, don't just sit there and stare at those 1,000 files. It's not that difficult, because now you know how to fix those quality issues. Thank you.